Okay, so this is our first lesson for financial literacy. So today we're going to look at something called simple interest and compound interest, plus one application called the credit cards, which we'll all be getting, which all of you will be getting when you're older. Okay, so first we'll look at simple interest. So it's a very basic formula. So we have interest, I, is equal to P, which is our principal. It looks like I forgot to include that P here, but it's listed later down. So it's our starting amount. So P is our principal. So our starting amount. I'll go fix that in the other notes. R is our interest rate. So yes, usually when we talk about interest rates, we usually mean percentage, but when we actually plug into these calculations and these formulas, we need to convert it to decimal form. And to convert back and forth between percentage and decimal, we have to either multiply or divide by 100, depending which way you're going. And T, usually we are looking at years. So time is using years. It can also be in months, depends on the situation. So here's our first question. We have Royce borrows $6,000 in order to renovate his master bedroom or master bathroom. And he plans to pay the money back in 1 year. So if the bank decides to charge him 2.25% interest per year, how much does Royce owe at the end of the year? So we're going to take our equation. We go I is equal to, so our principal is 6,000. So that's how much we are borrowing. So we're going to put that 6,000 in front. And then we're going to multiply it by our interest, so 2.25, so taking that 2.25%, we're going to divide that by 100. So that just basically means move the decimal over 2 spaces. So we get 0.0225. Right, so if we want to divide by 100, just take that. So we have 2.25. We're going to move the decimal point, place 2 over. So we get 0.025. And then for 1 year. So multiply through, we get 6,000 multiplied by 0.0225. That's $135. So when 1 year has come up, Royce has to pay back his original loan amount, so 6,000 plus 135. So he has to pay back a total of $6,135. This is how the bank makes money. So they're making money twofold actually. Actually, just onefold. But yeah, so they make money by basically, they lend you that money, and then at the end of it, they get 135. So if we scroll down, let's read this. So simple interest gives us a basic understanding of money owed or earned, so it can go both ways. If you put money in a bank, you're going to make money instead of having to pay back money. However, this equation is not super useful because what actually happens in the bank is that money is compounded. So let's say instead of 1 year, Royce decided to do that for 3 years. But what happens? The banks don't just simply take that $6,000 and then they multiply it by that 0.0225. They don't just do it if they don't compound it after 3 years. That's not how the banks do it. What they do is after each year, they take the money, they add it together. So we're gonna put that one back. You get a value, right? You got 135. They then take that starting 6,000, add that 135 to it, and then for the second year, they multiply 0.0225 again. So if we now go 6,135 multiply by 0.0225, in the second year you would owe 138. I'm just going to round it to keep it simple. So now the total amount you owe is 6,135 plus that new value, which is 6,273. And then they do it again for that third year. So now I'm going to multiply 6,273 multiplied by 0.0225. And the third year you owe 141. So you can see that each year you're progressively having to pay more and more. It doesn't seem like that much. Like each successive year, you paid extra $3, about. But when you're talking about larger quantity amounts of money or higher interest rates, because banks always charge you higher interest rates than what they would give you if you're saving money. So we add up this 6273 plus 141, we get a total owed of 6414 after 3 years. That's if you chose not to pay back. No, so what happens if we just multiply that 6,000 multiplied by 0.0225 times 3? We would have got, so 6,000 times 0.0225 times 3, we got 405. Add that to the 6,000, get 6405. You may say, oh, what? That's not the same. Yeah, so by compounding it, they're actually increasing the value that you'd have to owe. Right? So the more you compound something, the quicker that money you raise. Again, you may think, oh, it's only a $9 difference. But again, larger amounts of money, bigger interest rates, that compounding effect can cause significant differences in the amount we owe. So in the next video, we'll learn what's called compound interest formula. So it's basically a single formula that says taking into account this compounding effect using a single formula.